So we have to, so question is, obtain the two linear approximations of the function 6v square. This is non-linear graph, like parabolic function is a non-linear. So, and the 2 points are given near one point, like v equals to 5, other point v equals to 10, and this is the how to do the linearization. This is the approach which we are following using the Taylor series. And in the Taylor series you can find out how to, so higher order terms are neglected. This is a very nonlinear behavior, and we want to find out at this equilibrium point. And in our case, the equilibrium point, there are two, one is 5, one is 10. And I think the graph should look like, if I draw the graph, it should look like this is v, this is f of v, so it should be looking like a very non-linear area. So maybe at 5, this is at location, this is location 10. You have to linearize this graph, like draw a straight line. Linearization means draw a straight line at that point. Okay, that will help to reduce the complex problems from parabolic to just power 1 power of x. So in this case, this is v. So now how would you do that? You will use this equation. Okay, this equation. So I'm going to show you our parabolic function is 6v square, and so f of v minus f of vr equals to the slope, I would say m, and the x-axis v minus vr. This is the equation. And what is the slope? Slope, you have to find it out. Okay, slope of this form. So I'm going to, what is slope in our case? The slope is slope for the function this is my function. Okay, at equilibrium point, this is how you find out the slope at that location. Right now the equilibrium point is what, 5. Let's do for 5 first, how to linearize this at equilibrium point 5, and then let's do the velocity derivative of 6v square. Okay, so what is the velocity derivative of this function? 6 times 2 is 12v, correct? 12v, and then you will equate v equals to f5. So 12 times 5 is 60. So this is the slope is 60, correct? And then I will just write this down here. So m, it is 60, and v minus vr. In our case, what is vr? 5, which is the the point at which the linearization is occurring. Okay, equilibrium point. And this f minus fv, so we have to find out the new function. This is our new function, minus f of what is this? This is function 6 times v square at equilibrium point, which is 5. vr equals to, so I can write down 6 times 5 square. 5, what is this equals to? 125, correct? So I can write down 125 here. Can you verify? Or 150? One stress is 150. Why am I a bit different? I'm sorry, this is 150. So it is not 125. Thank you. It is 150. So the new equation is f of v equals to 60 times v minus 5 plus 150. Agreed? This is now linearized model. You don't see v square anymore. Okay, Do you see v square? No, you do not see at that location. You have already linearized a straight line equation. But you can further simplify it. Let's do the simplified version. Rearrange it. F of v equals to 60v minus 5 times 60. 300 plus 150. So the final equation is minus 150. So it has been linearized. Similarly, you can do the same method for the second equilibrium point, which is 10. So I would not do it for 10, but you have understood that how to do for 10. So let me stop the recording. So by the way, you can do it by